Okay, let's get started. This is our first help session. We have weekly help sessions on this time on Mondays, and there's a few important updates we have since the kickoff. Most recently, most importantly, we have Spacings Pro 0.39.7 and 0.39.8. Both versions should work for you. If you have one, you don't need to update to the other. That fixes the camera image issues that we're having where it would cause a crash of the platform to run the simulation. So that's necessary to update to those. Also, if you are running the sim, but ROS is not receiving any images, there is a firewall exception script that you can run in the STU3 sim folder on the user assets repos folder. There's a button to get to this folder without having to look for it inside of Space Teams. If you go into the Git repos page and then use the open local assets folder in there, and then go to repos, and it should be in there. The SGU3 sim, the sim files repo like that has been updated, which it fixes both. It adds a no camera mode, which will help, which will be higher performance if you don't need cameras when you're doing manual control, as well as it has a fix to the systems that we use where it will not crash as often, or like it will get rid of a crash that was happening if you were using one of the sims without running ROS in the background. Now we'll handle that a little bit more cleanly. So the instructions on how to do that change, how to update it are in this page here. You do this all within Space Teams, and it should work fine. So in case you're still getting started, here's the big picture, kind of a little bit of a summary of last time, but also a few other details. The install instructions is all started in the rules and info page. There's a competitor setup section, which tells you all you need to know. And the parts of the competition that you need are Space Teams Pro, the installation of that, ROS2, which involves getting it set up on Linux, and SU3 Sim, the sim files that are used for the competition. Next is to try out the sim. We recommend trying sim manual driving so that you can try out driving the rover for yourself. It's pretty fun. We had a conference that we went to last weekend that it was very fun. Everybody was trying out trying to drive the rover very fast and not flip. So you can get a manual sense of how the rover drives and how you might strategize on your rover autonomy code. Especially if you're going fast, you'll need to have a lot more dynamics kind of included in your thinking for that. Next, we already have with your once you set up Space Teams ROS, the I didn't include in the install things, but the setup instructions tell you what to do with that. Space Teams ROS, which is a has all the scripts that you need to set up Space Teams connection to ROS from after you install ROS. That includes the example client, which we have already written, which drives between the waypoints in straight lines. So it will likely not be able to get to the second waypoint, but it's good enough to get to the first one probably, and then it has a you can use that as your starting point for your own code. So once you know that that's working, that's a good place to make sure that everything's set up properly and you can continue on your solution from there. When making your own solution, there's a few ways you can do this. You could either modify the example client, as I said, which would mean that you would just take the example client code and add or remove things, including stuff like just tweaking the values that we already have in there, or maybe something like adding obstacle avoidance as some sort of override that stops the example client and goes into a different guidance to navigate around an obstacle. Or you can make your own ROS nodes. Everything is available to you to just make your own ROS nodes, like down to the level of you have those accelerator and reverse and steering commands, and you're free to make whatever you need. And we also recommend that you make use of the given data to improve your driving code. The example client does not include anything that processes the images, but using our starter code and the info on the Space Teams ROS wiki, you should be able to get the RGB and depth camera streams, possibly pass those to packages, ROS packages or other ROS nodes that process those and maybe bring them into 3D space to use for obstacle avoidance, or maybe you could also just do it image relative, where you see if there's something that's going to be in the path of your rover and navigate that way. And also the terrain data, which we'll be uploading more details on, that will be useful for example, if you want to um, base your path planning off of the slopes and altitudes and predict the driving difficulty between waypoints. More information that we'll add to both well, I guess either and both of the starter code as well as the wiki is the camera info. Right now, we only give from Space Teams ROS a stream of images in RGB and depth, and those are staying as how they are, but we need to add more metadata on top of them so that you can more effectively use those cameras in code. The standard for ROS2 seems to be this camera info struct, which is documented in the link there. And what we'll do is we'll have some code that publishes a ROS compatible camera info message and gives you the opportunity to use uh, some of those pre-made ROS packages to have for example, the depth camera info could possibly be made into 3D geometry once you have the camera info as well as the state of the rover relative to local frame. Other documentation we're updating includes the camera position and rotation relative to the rover body frame. So right now I think we don't have that up anywhere. We'll give you that info for where it is. You probably figured out by now that it's in front of the rover, like right in the middle, kind of like where the brand badge would be, like Jaguar, the Jaguar badge, like hood ornament would be that kind of placement. Um, and but we'll give you an actual geometry for that, so you can use that for your code. We'll also give some rover dimensions, say like the wheel span, the wheel radius, some things about the height and width and other axes, and where the body frame is relative to these key points. The rover drivetrain capabilities, like the wheel torques, the braking torques, all the maybe a little bit of information about the steering, especially how far it goes, the maximum steering angles, and the info about like the suspension as well. Terrain data, which will include like link to where the terrain data is that we used for the actual model of the terrain, which is useful, so you can use that for path planning and possibly find other terrain data that might be useful that's in the area. And that'll all be up tomorrow at some point. We will message again on the wiki, well, on the rules and info page, which has the same subscription thing that y'all can do. If there's a Y'all can do that to receive emails, I think, whenever there's a new message on there. Also, the qualification submission is coming soon. That's in, let's see here, 2 weeks. Yeah, so it's the Friday that is 2 weeks after now. So the requirements for the qualification sim are very simple, very low bar for this. We just require that you use our log message service to print hello to the Space Team's in-sim log and run the sim using the sim competition script, which is the right one to use for the scoring and final submission, and move the rover somewhere with the accelerator and reverse things. For example, you could it's totally valid to stay with the example clients, and that moves the rover somewhere. But the only extra requirement is to use our lock message service to print hello. So that proves to us that you've gotten it working on your computer and you know how to add code and see it working. And the main point of this is so that the submission, we can see whether your submission is valid and use that, give you feedback on that, so that we can, so that we know what so everybody knows what's involved and how to make a valid submission when we do the final submission later on. So the screen recorded video, we recommend like 1080p, 30 FPS. We have more information on the submission details on our rules and info page, and we'll publish a little bit more info, especially about the logs and exactly what we need in the source code later. Okay, that's a lot of info. We'll take any questions now, as well as we really want to hear from you all whether you feel that if there's any missing information in the info pages and the wiki.
Connor, we have one question in the chat. Maybe you answered it already.
Let's see, given the waypoint positions, those I think they appear in the example code. Let me check on that. Or Alex, do you know?
They should be provided in the example client Python file.
Right, so
There
that's
should
just
be
a
a list of NumPy arrays of positions.
right. And those are in local frame, Mars local frame.
They are in the local frame, yeah. Yeah,
Okay.
but we can provide both. Yeah.
Right. The qualification it just needs to have a valid submission. You don't need to the person asked if they need to achieve at least one waypoint to qualify. No, you don't. You can have a qualification with just running and having a valid submission.
Connor, can you publish a PDF maybe of these slides in the wiki?
Right. Yeah, and we should do that for the kickoff as well. We sent it out by email, but we can do that for these presentations as well.
Yeah, I mean, I'm going to publish the video, but for some reason, there's not a good time for people. Don't really know why. I would have thought it was a good time, at least for the people in Texas, and that's 20 something teams. But there's another 40 something teams that are all over the place, and the time is probably really bad. In any case, well, the video will be published on YouTube, and I probably should put the slides in the wiki.
Right. Do you participants have any ideas? If there's any conflicts, say maybe we're on the same time as like some live stream that everybody watches.
I don't know.
Yeah. Can't compete with I don't know. Who streams? Who's a big streamer? I don't know.
I could share a demo video now of one of the solutions, an
Oh yeah.
example.
So we have a team that is operating with our lab that's trying to make our own solution for this. Don't worry, they aren't competing, so they won't be able to win against you. But yeah, I'll let Neil show the his current progress.
Yeah. We optimize for video sharing. Let's see. All right, again, I'm Neil. I'm one of the developers at Sim Dynamics, and here's an example solution we have. So just to start out, I have this video paused, but we made this example Python matplot libplot showing this blue line is a spline trajectory, and the blue points are different waypoints. And so at the very start, it comes up with an estimated path of how to efficiently, or maybe not efficiently, depending on how good it is, um, get to all the different waypoints. But the idea is to avoid some of the rocks, and there's just different spline points along here that goes around obstacles that are identified along the way, and this can update through time. But let me go ahead and press play, and this red icon is where the rover is. And I'm going to move this window to the bottom right here. And currently this is recordings from, I had already reached waypoint number 7. And here I'm showing we're driving in the local negative X direction towards waypoint number 8. But several things are going on in the background here for navigation. First, it's the solution code is limiting the speed of the rover. So if it starts driving downhill, the accelerator command will be less. Uphill, it'll go up to try to maintain a relatively constant speed limit. Uh, and it also has uh, basic rock avoidance. So it's looking at camera images and trying to identify rocks to avoid. But some of these smaller rocks, like these here, it's hard to identify unless you slow down. So right here, it's getting to waypoint number 8, and here science sampling is happening, or the core sampling is happening. Um, but so this window here on the right is something you'll have to make it just a map, but it's an idea of instead of just having um, this simulation running, if you want to know what's happening, what the robot's thinking, could be good to make a plot like this showing the trajectory that the autonomous rover is taking, so you can figure out if something goes wrong, what went wrong, and uh, then you can go from there. So I suggest you don't have to, but making a map like this that updates in real time can help you solve some of the navigation issues you might have. And other things that happen are, um, as you can see here, there's a lot of big rocks there. And I think this uh, the rover accidentally drives into one of them. And so we have it wasn't identified in time. So we do in the code have a rock avoidance maneuver, or at least an obstacle. Once it detects an obstacle or hits it, it backs up and tries to go around it. Because depending on the lighting conditions, you might not be able to identify everything. So this one, it detected the velocity was 0. It waited for 2 seconds, and then it's doing this backup maneuver. And here it kind of backed up too fast, but it kind of got out of the way of the obstacle, and now it's trying to follow the path again. So you can even do things like that without the cameras, because if it's really dark and you can't see something, you might want to do something like that where you can tell the rover to back up on its own if it's not moving, so it's not just stuck there. So that's just one piece of advice. There's things you can do without the cameras, but it's best to use both different strategies combined together and have a kind of behavior tree that can help navigate to different points. And I definitely suggest trying things in the dark as well as in the lighted sections because once you get to different waypoints, you'll see the conditions change. So I think after we get to waypoint number 9 here, it gets pretty dark. We'll see.
Right. Also, you can change the simulation time yourself by using the period and comma keys whenever it's not doing the core sampling. That's invalid for the submissions, but you can do it by yourself if you want to change to a later time. And it doesn't really affect anything, like the ROS time doesn't jump forward or anything. The rover simulation in physics terms is all stuck to um, like real world time, but you can fast forward to change lighting conditions.
And on this, uh, the map again on the bottom right, this dashed green line is the trajectory it actually took, whereas the blue line was the planned trajectory. So there'll probably be things that change as you go along based on what you use with your sensors. What would you find with your sensors and what the autonomous rover decides to do? So definitely plan for changes or have the rover be adaptable based on any risks you might find.
Right. Oh, actually, what I just said may not have been quite right. The elapsed driving time will still count up with the simulation time. So that'll quickly hit an hour and lock you out if you advance time when it's not at one of the rock sampling waypoints.
Right.
I see the scale of time changing a lot when it's stopping to do the drilling, but how much time goes by during the drilling?
I think it's 4 hours. Is that right? Alex, do you remember?
Yeah, I believe it's about either 4 or 6 hours.
Yeah, so this is on the south. This is like 45 degrees south on Mars, and it's southern hemisphere summer now. So there's more sunlight than there was nighttime. So on average, you get a few more sun driving between waypoints than you do um, nighttime.
Right. I'm going to skip ahead to waypoint number 10 because I think it gets dark after that one. Let's see here. Oh, yeah. Okay.
Neil, the when it hits the rock, it's so the something about the vision algorithm didn't decide that it was a problem or didn't detect it in time, or what's happening in those cases.
Yeah. In those cases, it was driving fast and then, yeah, it didn't detect the obstacle in time. Um, so yeah, it
Also,
might be good sometimes to drive slower and kind of do a scan of, especially if you get to the top of a hill or a peak. This one is only kind of looking um, really close to it with it because depending on the angle of facing downhill or up, it can be hard to detect things.
and also feel free to continue asking questions in the chat or on mute and ask them as well. We have the rest of this time here, another 30 minutes available for that.
Now here at waypoint 11, um, this navigation controller didn't quite, it took too sharp of a turn. So you want to make sure when you get close to waypoints that you slow down and reach them all the way. Because here in a few seconds, let me skip ahead, you'll see that it tries to get to waypoint 11, but then it sees the plan trajectory has a sharp turn, so it actually kind of undercuts the turn and it doesn't get to waypoint 11. And I think it was also because of the slope. Um, it didn't mean to turn that much, but it wasn't expecting that slope there. Uh, so you can integrate the terrain data. This one actually wasn't using much of the terrain data at this point. So yeah, things like that can happen even if you're depending on your navigation controller and the slopes and things. You might miss a waypoint if you're not careful and drive slow.
So this algorithm is just trying to follow the trajectory. It's not its goal at the moment is not to get to that point, but to follow the trajectory that was planned for it.
Yes. Here it almost flipped over, but it recovered. So yeah, when it's in the dark like this, it's especially those small rocks. The code that rewrote couldn't really detect those small rocks, so that's why it almost flipped over a few seconds ago. So you might need different algorithms for image and object identification in the bright conditions versus the dark conditions.
Right. The limit for the camera exposure is 5 for the EV. You can change to 5 now. You can't. You're not running the sim interactive right now. You're just playing the video. But if
Yeah,
you
just
change
playing
the
video.
camera in the sim on your own perspective, using that EV slider on the top right, you can see what the camera should be able to see. And you can also use RViz or some other method of displaying the images as they come in to see what the camera is seeing.
It's really cool to see this, Neil. I'm sure there's lots of improvements that you can make based on what you see here, but it's pretty cool to see it working.
Yeah. And it helped a lot to have this visualization of the trajectory. So, because if you're just watching the simulation, you might not know what it's trying to do.
Right.
Um, and I didn't explain earlier, this little line, it might be hard to see on the stream, but I'm showing the orientation of the front of the rover with that little line. You can use whatever icon you like. I just made a simple square and a line sticking out of it. Now here, I think waypoint number 12 is getting to is behind a rock. and then it bumped into this rock and then tried to go around, and then it actually missed waypoint 12. So that's something else to consider. If you're avoiding obstacles, make sure you're not also avoiding the waypoint. And for this specific rock avoidance mode, when it detected a rock, it tries to back up. But if you're backing up down a hill, you might swerve or drift like that. And so here, I think it's trying to go to waypoint 12, or maybe it does make it, but for some reason it doesn't stop or doesn't slow down enough to do the sampling command. Something weird happened there.
I think in the example code, it is constantly checking if it is close enough to a waypoint and then does sampling if it is. Is that right?
Yeah, that's correct. I think what actually happened here is I think the camera thought there was an obstacle there, a rock, and then it backed up and went to waypoint 13 instead.
I think I should clarify the example client code doesn't actually sample all the time. You have to call that command yourself when you're within the right like proximity of a waypoint, which is all given in that code. Um, but it's totally valid to also be sampling all the time, and it'll just bounce back at you and say you're not close enough to waypoint. So
Yep.
the moment it works, it will freeze your rover dynamics basically, and then allow you to sample at that waypoint. So that's
Right.
totally valid to do. Yeah.
Does your algorithm know which waypoint it's trying to go to, or is it just looking at the path?
It's just looking at the path but well, it doesn't know if it's near a waypoint and it sends a sample command, but that's happening in parallel with the driving. So if it doesn't
Right.
slow down enough, it skips the waypoint even though it tries to sample.
So you probably need
So
something that I mean knows that it was trying to go to a certain waypoint and the distance is increasing from that waypoint. So it needs to turn around and go back.
yes. And I paused here just to show here's one, even though in the simulation view it looks like you can see a lot, because this is the third person view. In the actual camera, we'll only be able to see what's lighted up here, and everything else based on the exposure will be really dark. So you might be able to
Yeah.
see things while you're watching the simulation, but the camera might not see the same view as you. It will definitely be
Depending on
different.
conditions, you can use like take multiple images at different exposures to try to get the like say if there's some sun on the horizon like that's lighting things up through the atmosphere, that could help with seeing the things outside of the cone of vision of the headlights, but you'll need to take multiple images with different exposures to capture everything.
And on this map, I zoomed out. You can see where it started here, and it went along this path. Um, and then after this, the solution didn't get to more waypoints. It was trying to go back to waypoint 13, which it skipped, and then something got confused with the controller, and it just drives in circles for 3 or 4 more minutes, and it keeps bumping into this rock as well.
Yeah.
So that's something that's fixed now. But when I recorded this video, it just kept trying to go back to the waypoint it skipped.
I think the blooper videos are going to be more fun to watch than the solution videos.
Oh
Yeah.
yes.
Yep. So that was just an example of what once you get your example code, or when you run the example code or have your own code working, it will look like this. And uh, I suggest having some way to visualize what the rover is thinking, such as this map, or it could be anything that you have.
Very cool.
Mhm.
And if y'all have any more questions after this workshop, feel free to post them in the discussions page on GitHub. It's the same place, documentation. We'll try to get back to you pretty quickly.
All right. Last call for any questions. Otherwise, we'll post this and advertise it so people can watch the blooper video. Version 1. All right. Thanks, guys. That's great. Um, they have to do better than us. Um, so far, we got the only solution we know about. So,
Yep.
Uh-huh.
all right. Thanks, everybody. All right, great. We'll stop here and we'll post all this.
Okay.
Thanks. All right. Bye bye.
You're welcome. Bye bye.
Bye bye, everyone.